Hello everyone. In this video, we are going to be considering the multiplication of matrices. This is a continuation of the series of videos we've been working on matrices. To see one of them, just click on the link at the top right hand corner of the screen. The first one we are going to consider here is scalar multiplication. So we all know what a scalar is. Of course, in this context, a scalar is just a constant. 1, 2, 1 half, -5, and so on and so forth. Any constants. So how does a scalar multiply a matrix? Let's consider this 3 by 4 matrix. It has 3 rows and 4 columns. If alpha is a scalar, then alpha p, the product of alpha and p, is going to be equal to alpha, then multiplying. Thus, the scalar is going to multiply every single element in the matrix. So this is just going to be alpha A, alpha B, alpha C, alpha D. This is scalar multiplication. The next one we are going to consider would be the multiplication of two matrices. Two matrices can only be multiplied if the number of rows in one is equal to the number of columns in the other, and of course, if the number of columns in one is equal to the number of rows in the other. For example, if A is a matrix with 2 rows and 4 columns, then we can only multiply another matrix that has 4 rows and 2 columns with it. So we can see here that the number of rows in the first one is equal to the number of columns in the second, and also the number of columns in the second is equal to the number of rows in the first. Let's take another one. Let's have matrix Y and Z. If the order of matrix Y is 1 by 2, then in order for the multiplication to work between Y and Z, Z must be a matrix of order 2 by 1. So generally, an M by N matrix can only multiply an N by M matrix. This is the rule for multiplication. Let's take the first example. Now, here is the problem. So we are going to solve. A is the matrix 1, 4, 3, 5, 3, 1. So we've got 2 rows and 3 columns. So A is a 2 by 3 matrix. And here we've got 3 rows and 2 columns. This is a 3 by 2 matrix. So we can see that the number of rows in A equals the number of columns in B. And similarly, the number of columns in A is equal to the number of rows in B. So these two matrices can be multiplied. The first question here requires us to obtain the value of 2A. This is an example of scalar multiplication. The scalar here is a positive 2. So this is just going to be 2, then multiplying the matrix 1, 4, 3, 5, 3, -1. So as usual, the scalar is going to multiply every entry inside of it. So this is going to be 2 times 1, 2, 2 times 4, 8, 2 times 3, 6, 2 times 5 is 10, 2 times 3 is 6, 2 times -1 is a -2. Okay, the second one, we are asked to obtain the value of AB. So AB is just going to be 1, 4, 3, 5, 3, -1. That's A. Then B, 0, -2, 7, 3, 4, -5. Now, this is how matrix multiplication work. Successive elements in the row would multiply successive and corresponding elements in the column. So here we would have 1 times 0, that's 0, then plus 4 times 7, plus 3 times 4. Then we are still focusing on the first row. We are going to move to the second column. So 1 times negative 2 plus 4 times 3 plus 3 times negative 5. So we are done with the first row. Similarly, the elements in the second row would multiply corresponding elements in the first column. When we are done with that, the same elements in the first row, in the first matrix, would multiply corresponding elements in the second column. So we would have 5 times 0 plus 3 times 7 plus negative 1 times 4. We're done with the first part. We will move to first row, second column. That's 5 times negative 2. 3 times 3, then plus negative 1 times negative 5. Therefore, we would have AB is going to be 1 times 0 is 0. 4 times 7 is 28. 4 times 3 is 12. Then we'll move to the next one. 1 times negative 2 is a negative 2. 4 times 3 is 12. 3 times negative 5 is negative 15. The next one, 5 times 0, that's 0. 3 times 7, that's 21. Negative 1 times 4 is a negative 4. The final part, 5 times negative 2, that's negative 10. 3 times 3 is 9. Negative 1 times negative 5 is a positive 5. Therefore, our final answer, AB, is going to be equal to 28 plus 12. This is 40. Minus 2 plus 12, that's a plus 10. Minus 15, that's a negative 5. Then 21 minus 4 is 17. Negative 10 plus 9, that's a negative 1. Plus 5, that's a positive 4. It is clear that this matrix is a 2 by 2 matrix. AB is a 2 by 2 matrix, which we got by multiplying a 2 by 3 matrix with a 3 by 2 matrix. So we can conclude that whenever an M by N matrix multiplies an N by M, we would always get an M by M.